Hi guys, in this video we'll be discussing the daily Leetcode challenge for 3rd of January, and the problem's name is delete columns to make sorted. The problem states that you are given an array of n strings and the name of the array is strs, and all of the strings are of the same length. The strings can be arranged such that there is only one string on each line and it would form a grid structure. For example, for this particular array that has been provided to us, so the strings over here are ABC, BCE, CAE. We write one string on each line. So we have ABC on the first line, BCE on the second line, CAE in the third line. So we form a grid structure. So grid is nothing but a combination of rows and columns. So when we traverse horizontally, we say that we are traversing row wise. So in this row ABC is present, and this is the row 0, this is the row 1, this is the row 2. When we traverse vertically, we see we're traversing a column. So this is the column 0, this is the column 1, this is the column 2. So now what they are asking is that you want to delete the columns that are not lexicographically sorted. So what lexicographically sorted means that a certain character cannot occur after another character if it's smaller than that. So over here, let's say we had 3 characters C, B and A, or let's say we had just 2 characters C and B. Now B is smaller than C, right? But over here B is occurring after C, hence it's not lexicographically sorted. Let's say we have another example, Z and F. Now F is smaller than Z, but it's occurring after Z, hence it's not lexicographically sorted. We have A and D. D is smaller than A, D is greater than A, and it's occurring after A. So this is fine, and this would be lexicographically sorted. So this is right. The other two are not lexicographically sorted. With that point, let's move ahead. So we have to delete the columns that are not lexicographically sorted and then return the count of such columns. So they have also provided us with an example. In this particular example, they are saying that the strings array that has been provided to us is CBA, DAF and GHI. So let's try to understand it with this particular example. So this is the example they had provided us. So let's try to write it in a grid format. So this is the grid we have formed. So in the first row, I'll be having CBA. In the second row, I'll be having DAF. In the third row, I'll be having GHI. So now, is the column 0 sorted? So this is the column 0. So this is the entire column 0. So is it sorted? Yes, it's sorted. Is column 1 sorted? It's not, because A is smaller than B, but it's occurring after B itself. So it's not sorted. Is column 2 sorted? Yes, A, F, I. So all of the characters are in the lexicographical order, hence it's sorted. So we'll just return 1 because there's only one column that's not sorted. So so this was very easy to do by looking at the structure. But how do we write a code for it? So if you have worked with 2D arrays before, you'll know that generally we traverse a array in the row wise fashion. So what row wise fashion means is that, for example, this is the grid we are talking about, or a 2D array. So this is 0 0. So we'll firstly be at 0 0, then we'll go to 0 1, then we'll go to 0 2. In the next iteration we'll go to 1 0, then 1 1, then 1 2. In the last iteration we'll go to 2 0, 2 1, 2 2. However, over here we'll have to check if a certain column is sorted or not. So this kind of a traversal won't make sense. So we cannot use this. What we can instead use is a column wise traversal. So we can start with the element 0 0. We can go to 0 1. Oh sorry, we can go to 1 0 and then 2 0. In the next iteration we can go to 0 1, then 1 1, then 2 1. In third iteration we can go to 0 2, then 2 1, then 2 2. So how would we do that? So just to make it clear, this is called the row 0, this is called the row 1, this is called the row 2, this is called the column 0, column 1, column 2. Now in the first iteration we were going for column 0, so we'll have to go through all the elements that are present in column 0, firstly at row 0, then row 1, then row 2. So we can say, so let's just suppose we have a single column right now. So let's suppose this is the column we are having, this is the column what we are having, and it has elements C, D and G. So how we'll do it? We'll try looping through all of the indexes. So we can say for row equal to 0 till the time row is less than n, row plus plus. over here n is 3, and then in the loop we can have the element by referring to array or grid, whatever is given to us. The first column, that is the 0th column over here, and the corresponding row. As simple as that. And now we can perform whatever computation we want to perform on this particular element. So when we'll go for the second iteration for this, so row would have been incremented by 1. So in the first iteration row was 0. In the second iteration, when we'll follow it, it would become array 0 1. Third iteration, it would become array 0 2. Hence by this we can easily traverse in the column wise fashion. But over here we don't only have a single column, we have multiple columns, right? So we have column 0, we have column 1, we have column 2. So how do we do that? So what we can do is, we can say that there's an outer loop that loops over the columns itself. So it goes for column 0 till column m and column plus plus. So now what would happen is, once this certain loop is over, it will go back to the upper loop. It will get incremented by 1. So now in the first iteration we'll be going for column 0. In the next iteration the column would have been incremented by 1. So we'll be checking for first column itself. In the next iteration we'll be checking for the column 2. So that's pretty easy to do, I guess. Also, how do we check if it's lexicographically sorted or not? So let's try to understand that if you're given with just a single element. So let's say you're just given a single element A or a single element B. So is this lexicographically sorted? Obviously, because we are having just a single element and we have nothing to compare it with. So we can say A is lexicographically sorted and B is lexicographically sorted. So basically, if we have a single occurrence of an element, or we have a single element, then it always is lexicographically sorted. So there's no point in starting the row. Over here we're starting the row with 0. There's no point in starting the row from 0 itself, because the first element is always lexicographically sorted, right? If it was only a single element, it would have been lexicographically sorted. So let's start it with row 1. Row 1 until the time row is less than n and row plus plus. What we can say is, if the array that would be now given by the row and the column specified is less than, if it's less than the previous element, so the previous element in that particular row would be given by array row minus 1 and column, then this particular element or this particular row, this particular column is not lexicographically sorted. Hence we can increment, we can say it's not lexicographically sorted. So we can increment some variable. So let's say I call it res, increment some variable which would denote the number of columns that were not lexicographically sorted, and I can break this particular structure. Now the reason I'm breaking over here is, if I don't break it over here, it will check again for the same column. For example, if the elements were something like C, then we had B, then we had A. So we want the rest to be incremented by only once, right? But what would happen is, firstly it will check for it if we don't have a break over here. So firstly it will check if B is less than C. So it will say yes. So it will increment rest to 1. Then again it will check if B is less than if A is less than B. It will say yes, and it will again increment rest by 1. So this is not what we want. We just want to increment our result variable or the number of rows by a single count if we find an ambiguity in a certain column. Hence we are breaking over here. So as soon as we find an ambiguity, we'll break. I think the code is pretty simple. Let's understand the time complexity. So the complexity for it is order of m into n. That is the case because we are checking for all the characters that are present. Hence, since we are having m into n characters, or I can say I'm having n strings where each string has a length of m. So I'm having m into n characters in total, and I'm traversing all of those m into n characters. Hence my time complexity for this is order of m into n. What is the space complexity? The space complexity also is order of n into n, because the array itself takes order of m into n space. However, the auxiliary space complexity is order of 1, because we are not introducing any more space into this problem, right? We are doing it in constant space. So let's try to code this particular problem. So for the code, what we can say is that, okay, So let int n is equal to the size of that particular array, so it would be string size. Let m be the size of any of those strings. Since all the strings are of same length, it shouldn't matter. Then let me introduce a variable res. So res would contain the number of columns that are not lexicographically sorted. I'll return res at the end. Let me start a for loop for the columns. So I'll say int c is equal to 0, c is less than r, c plus plus. Okay, c is less than m, sorry. For int r is equal to 0, r is less than n, r plus plus, and then I can check. So r can start from 1 as discussed if the strings we had at row and this particular column, if it's less than the previous element, so r minus 1 and c, then I can increment my variable and I can break this particular loop. So that seems fine to me. Let's try this out. It's working for the simple test cases. There's some issue with Leetcode, I guess. Cool, it worked. So you can see that this particular code worked and it has passed all the test cases as well. So that's it for this video. Let me know if there's any concept which you are not able to understand, or if there's any other problem on which you want me to make a separate video. Thanks a lot, guys.